In a previous episode, we'll call it the prequel, we saw how to use a custom interpolator to interpolate a data structure that held rectangular values. Right? So flex effects by default work with numbers, and in Flex 4, the flex effects can deal with other objects, but you need to tell us how to interpolate for them. So in that previous episode, we had an interpolator called rect interpolator that you could animate the rectangular values, and then we would ask you how to interpolate these objects over time. Today, I'm going to show you the motivation for that interpolator, which was a question that someone had asked on one of my blogs or a forum saying, how do we actually resize an AIR application? How do we resize the native window underneath? And I was playing with it, and my original take on it was, well, it's easy. You just, you set an animation. We can target arbitrary properties on arbitrary objects. You animate X, you animate Y, you animate width, and you animate height. And so I wrote some simple animation code, and I ran it, and it looked horrible. And it turns out that we have a pretty direct connection in AIR to the native window data structure. So when you say set X, it'll go ahead and it'll set X immediately, and then we'll catch up to it later. Or in particular, when you set width, then Flex needs to catch up. Okay, well, you set the width on the native window, then the Flex layout needs to adjust, all that stuff. So that's all fine. It takes a frame to adjust for that. But the real problem was that we were setting X, and then we were setting Y, and then we were setting width, and then we were setting height. And it's really an atomic operation. You kind of want to see all of it happen at once. Otherwise, it's not really the effect you were looking for. So the rect interpolator that we saw in that earlier show is actually a direct result of me trying to get this demo working for a question that someone had asked, is how do we effectively resize an AIR app on the fly? So let's go ahead and see that AIR application. So we'll run this little code. The width and the height text input fields reflect what the current width and height is, and we can change those on the fly. So we'll say I want this to be 300 wide by 250 high. And we'll click the resize button. It fades the controls out and then resizes the window. I threw in the fade there. It seems a little gratuitous perhaps, but you're actually going to be sort of moving this thing over time, and your controls are going to be jittering a pixel here and there as they adjust to stay in the center all the time. So it actually works out better to just fade them out of the way, make the window resize to whatever you want, and then fade them back in, right? So now let's see how the code actually works. So we can go in here. We've got a bunch of simple getters that I implemented on the application so that I could get the native X, Y, width, and height of the window itself. First of all, I should point out this is an AIR application. This is a windowed application as opposed to the application class you would normally see in Flex. AIR has a windowed application. And then underneath it, it has this native window object. And this is what you actually change if you want to set the position or the size of the underlying window of the application. It's not something you can really do in Flex because normally when you're not in AIR, because you're running inside the browser, you can't tell the browser how big to be. You just need to run within whatever window it is. But for AIR applications, these are standalone desktop applications, you can go ahead and size the position and position the window appropriately. So these are simple getters on those values. And then finally, we have one for the rectangular bounds overall. So we can say, okay, these are the rectangular bounds of the window, or go ahead and set the rectangular bounds of the window to what I'm telling you. And then we have a button. You click on the resize button, and it's going to go ahead and calculate the value of this rect object that we've created up above. We have a private variable here, rect. So it's going to calculate the value based on those text input fields. So it's going to say, okay, these are the values that I'm animating to. And then it's going to play the resizer effect. And the resizer effect is up here. It's this sequence, which is going to play a fade to fade the controls out. And then it's going to play an animate on one single property, which is the native bounds property defined above. And then it's going to play a fade to fade the thing back in. So the fade operates on the controls, the text input fields in the button. And it fades out to 0 over a period of 300 milliseconds. We want a pretty quick fade. And then we're going to animate the native bounds property, and we're going to go to a value of the rect that we defined down here. So we set the values of this rect object based on those text input values. And we're going to pass in a custom interpolator because flex effects don't know how to interpolate rectangular values. We know how to interpolate numbers, but if you've got something else coming at us, you need to tell us how to interpolate between them. So we're going to go ahead and set a custom interpolator on this object. And then we're going to go ahead and fade the things back in after the after the resizing motion is done. We've seen this in a previous episode, but let's go ahead and look at the rect interpolator very quickly. It implements the interpolator interface, which is new in Flex 4. And it says, when I get an interpolate call, which I will on every update of the animation, then I'm going to get the elapsed and eased fraction of the animation, the start value, whatever this thing was when you started, I'm going to pass it directly into you, the end value that you're going toward, and then you're going to return back an interpolated value. So this is basically going to give you the value the rect started from, the value that you told it to animate to, and the elapsed fraction in between them. And then for those three parameters, we can calculate the value of the in-between rectangle. So basically, we take each of the components, like the x value, and we say the new x equals the starting x plus the fraction times the delta between the end and the start x. It's a simple parametric calculation. All we're doing is breaking out each of the component pieces of the rectangle and interpolating each one of those individually, and then creating a new rectangle and passing it back. So then we have our full animation. We're basically interpolating a rectangle in one atomic operation so that we're changing the width and the height and the x and the y all together instead of individually making the windows sort of pop around at different times. And we're using this custom interpolator to help us do that. If you want to check out the code for this application or other related applications, go to my blog at graphics-geek.blogspot.com.